Okay, we're solving more inequations with the pronumeral in the denominator. First one, solve 1 over x is less than 3. Okay, the first thing you need to do is look at this denominator. What will make it go 0 to 0? It will be x equals 0. So that will make that undefined if x was equal to 0. So x cannot equal to 0. All right. Next step is you need to multiply both sides by the denominator squared. So it'll be 1 over x times x squared is less than 3 times x squared. Okay, that will become x less than 3x squared. Okay, so there'll be 0 is less than 3x squared minus x, and 0 is less than, just factorise, so you have x outside of 3x minus 1. And just leave it like that for now. And let's solve this quadratic inequation. So you're going to solve 3x minus 1 equal to 0. And you'll get x equals 0 1/3. All right. And then you just simply place that on a number line. So you got 0, you got 1/3. Remember that x cannot equal to 0, so you're going to have to put an open circle when you plot that 1 on 0. And a third, you're also going to put another open circle because the inequality is less than, it's not less than or equal to. So it's not equal to, you can't colour in that circle. All right, doesn't include 1/3. All right. So now we take a test point. Okay. You can take a test point outside or inside. I'll take the test point x equals minus 1. Okay. And we're going to sub that into the original expression, 1 on x less than 3. Right, so I'm going to get 1 on minus 1, which is minus 1 is less than 3. Okay, that is a true statement. Right, I took my test point out here at minus 1 and it's a true statement. So that means that the values of x will be out here and out here. All right? Okay, so therefore we can write our solution that x is less than 0 and x is greater than 1/3. Okay, example 2, we have 6 over x plus 3 greater than or equal to 1. We have a pronumeral in the denominator, so we have to follow the process. Okay, first step, look at the denominator. What will make that go to 0? Well, clearly, x cannot equal to minus 3 because minus 3 plus 3 will give you 0 and therefore that will be undefined. Okay, once we've done that, we take the denominator and we square it and we multiply both sides by that. Okay, right, so that will cancel one of those. So you've got 6x plus 18 is greater than or equal to x squared plus 6x plus 9. Okay, so you get 0 is greater than or equal to x squared minus 9. You can write it this way around, x squared minus 9 is less than or equal to 0, and just keep that for now. All right, let's solve x squared minus 9 equals 0. You'll get x minus 3, x plus 3. So therefore, x is equal to plus or minus 3. All right. Now on the number line, you go to put those points on the number line. You got minus 3 and you've got plus 3. All right. Now it says here that x is not equal to minus 3. So on minus 3, you're going to have to put an open circle. And on 3, you can put a closed circle because it includes 3 because the inequality does say so. Okay, now we'll take a test point. I'll take a test point of 0, okay, in the middle. So I'll simply write down test point x equals 0. Sub it into your original. Okay, so you get 6 over 0 plus 3 is greater than or equal to 1. Is that a true statement? Well, 6 on 3 is 2. 2 is greater than or equal to 1. That is true. Okay, that means where I took the test point, all those values are true in between. So you just simply conclude that therefore minus 3 is less than x, which is less than or equal to 3. It's minus 3 is less than x, not less than or equal to, because it's an open circle. Okay, and it's less than or equal to 3 because that's a closed circle. All right, so there's your solution to that one. And the third example of an inequation with a pronumeral in the denominator is this one. Y squared minus 6 over y is less than or equal to 1. Okay. Now, clearly y cannot equal 0. So you need to write that down first. Right. Then the next thing you have to do is multiply both sides of the inequation by the denominator squared. So you're going to multiply both sides by y squared. Like that, and then cancel, so you will end up with y outside of y squared minus 6 is less than or equal to y squared. Okay, expand, y cubed minus 6y, bring the y squared over, minus y squared, okay, and then there's a common factor of y, so it's y outside of y squared minus 6 minus y. Right. Write that out nicely. So you've got y squared like a trinomial, so you can factorise that trinomial. All right. And then, so keep that there in a box and solve that trinomial, or that whole thing. It's not a trinomial really, it's got the other y, equal to 0. Okay. So that will become y, 2 brackets equal to 0. Factorise that trinomial in there. All right, leave that y where it is. So that'll become y minus 3, y plus 2 when you factorise that. Okay, so therefore you're going to get 3 solutions. Y equals 0, 3, and minus 2. All right, so let's go and put those on an x-axis. Okay, so I've got 0 here. I've got minus 2 here, and I've got 3 over here. Okay, just check that that's correct. Now, we did say that y was not equal to 0, so we need to put an open circle on the 0. And we do have a less than or equal to sign, so the other 2 points are going to be filled in. They have to be included, all right? Now, what we do is we take a test point. Okay, take a test point. This region, this one, and this one. Okay, we need to know where which values hold, will make this statement true. So you have to take a test point. First test point, I'll take here at minus 3. So when y equals minus 3, okay, I'm going to put that into my original. So I get minus 3 squared, which is 9. 9 minus 6 is 3. So it'll be 3 over minus 3, less than or equal to 1. Okay, that means that minus 1 is less than or equal to 1. That is true. So therefore, solution's there. Okay. If you took the test point y equals minus 1, then you would get minus 1 squared is 1, 1 minus 6 over minus 1, less than or equal to 1. You get minus 5 over minus 1, 5 is less than or equal to 1. That is not true, so just cross that off. You're not going to get any solutions in there, okay, between those 2 points. Take another test point from 0 to 3. So when y equals 1, just put a cross there, so you know you're taking it. So y equals 1. Substitute into the original. 1 squared is 1. 1 minus 6 is minus 5 over 1, less than or equal to 1. Minus 5 is less than or equal to 1. That's true. So tick that part. And then let's just check a value greater than 3, let's say 4. So y is 4. We substituted, we get 4 squared minus 6 on 4, less than or equal to 1. That's 16 minus 6 is 10. 10 over 4, okay, is 5 over 2, which is 2.5. That is not a true statement. Okay, so we put a cross there. All right, so that's where our values are, there and there, okay, which will satisfy this inequation. So we simply write x is less than minus 2. I'll just write that right down here. Okay. X is less than or equal to minus 2, I should say, okay, because it's a coloured in circle. And then you say 0 is less than, not less than or equal to, less than. It's supposed to be y, isn't it? Sorry, I'll just go back. It's y. We are dealing with y. That's what's in the equation. All right, 0 is less than y, which is less than or equal to 3.